Hello girls, this is your awesome sick teacher today. Now today we're going to talk about indefinite integral. So what are indefinite integrals? Indefinite integrals is pretty much the same as definite integral except for one thing. Indefinite integral is finding a function instead of a value. So remember what we did before for definite integral. For example, integrating from 0 to 2 x squared plus x dx. I have the brackets on, girls. That equals to x cubed over 3 plus x squared over 2. And that's 0 from 0 to 2. And that will give us 8 on 3 plus 2 minus 0, 0. And what it comes out, it's a number, which is a value. I don't know what that is. However, for today, indefinite integral, what it comes out would be the function, because we are not interested in the value. So the most important bit in indefinite integral is we are still using the same power function rule, which means if I'm integrating x to the power of n, your result will still be x to the power of n plus 1 over n plus 1. Now, however, we don't have any values to sub in right now, and instead we plus a constant c. Now, this constant c is very, very important for indefinite integral. So this is not just for the final result. It's when you finish integration without boundary, which means it's an indefinite integral, plus c is added. Now, why do we have such thing as plus c? Let me show you a very simple example. So for example, if I want to ask you y equals to x squared plus 3x plus 5, let's find the derivative. So dy over dx is equals to 2x plus 3, because the derivative of 5 is 0. However, if I give you another function y equals to x squared plus 3x minus 10, the derivative is still 2x plus 3, because the derivative of negative 10 is also 0. Well, in this case, what happens if I integrate 2x plus 3? Which function I will get back? X squared plus 3x plus 5 or x squared plus 3x minus 10? We're not sure. So therefore, when you integrate such a function 2x plus 3, you'll get x squared plus 3x plus a constant c, which we don't know what that c is. However, whatever constant, the derivative is always equal to 0. There's nothing new in here. Whenever you see an indefinite integral, when you finish the integration, you just plus c there. And you're still using the same rule. You add 1 to the power and dividing by the new power. However, there's one more thing we need to understand today for indefinite integral, which also applies to definite integral later. If I am integrating a linear function to the power of n, in this case, now most of us will think simply just add up to 1 more to the power and divided by the new power. However, it's not that easy. Well, it's not that hard either. All you need to do, at the bottom, you also divide it by a, which is the same value of the coefficient of x in here. Okay, so we'll be talking about this as well as the normal indefinite integral. Here is some example, very quick. Now girls, I am moving a little bit faster because you can pause your video anytime you want. So if you need time to write this example down, go for it. Okay, first one, if I'm integrating 8 dx, remember when you integrate a constant, you just got ax, but that's not the end of the story. It's ax plus c. Okay, part B, if I'm integrating 12x cubed, now as I said before, if you have a constant there, take it out to make your life easier. So before you do integration, take it out, and when you integrate x cubed, you got x to the power 4 over 4. Now remember, even though this is not the final line for your answer, you plus c straight away once you have finished your integration. In other words, this line has no integral anymore. This line has no integral anymore. Therefore, we plus c. And so therefore the final answer is 3x to the power 4 plus c. Okay, so again, it's nothing different from what we did before, except for the plus c instead of putting the values in. Example C. In this one, we have 3x plus 1 to the power of 5. Now in this case, remember we're just using the new rule. That means we are adding up the new power. 5 plus 1, that gives you 6. And over, not just 6, but also 3 times 6. That is the leading coefficient of the first function, and multiply by the new power at the bottom as well. And don't forget again, plus c. And in this case, you should have 3x plus 1 to the power of 6 over 18 plus c. Part D. Next one, we would have 5 minus 2x all squared dx. Now in this case, it's exactly the same. We would perform integration as usual. Make it a 3. And the bottom is whatever the coefficient of x multiplied by 3. But the coefficient of x is negative 2 in this case. So make sure you write negative 2 multiplied by 3. And again, don't forget plus c, because that is the line that you finish your indefinite integral. And in this case, you may write it negative 1 on 6 outside, 5 minus 2x to the power of 3 plus c. You can also write negative 5x minus 2x to the power of 3 over 6. It's your choice. Let's do a few more examples together. Let's say it's 4x plus 1 to the power of 8 dx. In this case, it's 4x plus 1. Let's put the new power 9 and multiply the bottom by 4 times 9 and then plus c. And that should give us 4x plus 1 to the power of 9 over 36 plus c. Same thing again. Now, what happens if we have not just the normal function? Let's say integrating 12 over x cubed dx. Now be very, very careful, girls. In this case, the x cubed is at the bottom. 12 stays at the top. So we have to write it as 12 multiplied by x to the power of negative 3 dx. And everything just follow. You can take the 12 out, and let's do the integration. So 12 x to the power of negative 3 plus 1 is x to the power of negative 2, and over the new power negative 2. Again, don't forget plus c. Again, plus c is not just a decoration for the end of the question. It is whenever you finish your integral, you need to add that. So that gives you negative 6x to the power of negative 2 plus c. Now, this could serve as a final answer. However, the question was given in fraction form, so I might as well just give it back into fraction form. But both of them are correct. None of them is simpler than the other one, unless I specifically say to change it back into fraction. That's all. Okay, now let's take a look some more A, B, C, D, E, F, G. Next one is G. More advanced question. In this case, we have the combination of what we had done before. We're integrating 1 over 3x plus 4 all square. Now we are changing 3x plus 4 all square into negative index form. And that's exactly like what we did before in here. Okay, so we are adding 1 to the power to become negative 1. And then multiply the 3 by negative 1 as well. And then plus c. And that will give us negative 1/3, 3x plus 4, negative 1 plus c. Now, once you have done the plus c, it's always there. So it becomes negative 1 over. Again, this line is correct already, but I use whatever form they give us at the beginning. So they're both correct. All right.